In today's video, we are going to be solving a problem by finding an equivalent ratio. So in particular, we're going to talk about equivalent ratios. Evidence-wise, we're going to connect our prior knowledge about ratios to describe a relationship, just how do you make one. You're going to connect fraction manipulation to ratios. How do you change a fraction? There's a reason I said fractions are the best way to show a ratio. Finally, we're going to apply equivalent ratios to real life, in air quotes, scenarios. Learning experiences there, it's a little bit stacked today, but most of it should be pretty quick. So let's move on to our first example of finding equivalent ratios. Example 1, we are going to find an equivalent ratio for 2 bananas to 4 apples. Additionally, we're going to find out how many apples we would have if we have 10 bananas. So the first thing to do here is just to write down our initial ratio. We have 2 bananas to 4 apples. Now, to find an equivalent ratio in general, which would be this first part of the problem, all we need to do is we need to multiply both the top term and the bottom term by some number. It doesn't matter what we choose, as long as it's not 1 or 0. Those aren't really going to help us at all. So let's say we want to multiply these by 2. 2 times 2 is 4. 4 times 2 is 8. So we now have an equivalent ratio. We have 4 bananas, which I cannot spell, for every 8 apples. Real easy. Nothing really to it. We could also use division. So if instead of multiplying by 2, we divided by 2, 2 divided by 2 would be 1. 4 divided by 2 would be 2. So we could also say for every banana that we would have 2 apples. So pause the video if you need for a second. Write this down. It's real easy. You just multiply or divide your original ratio to find a new one. Sometimes we need to do something a little bit more in-depth. So for example, if we start off with our ratio of, let's use the second one, 1 banana for every 2 apples, and we want to make a ratio where we would have 10 bananas, and we want to figure out how many apples we'd have, we have to do a little bit of thinking to figure out how we can go from this term to this term. And unlike in our last unit where we could use 4 operations, now we can only use 2. We can only use either multiplication or division. I don't think there's anything useful that we could divide 1 by to give us 10. So instead, what if we multiply this by 10? So times 10. If we multiply one of our terms by 10, we have to multiply the other one by 10 as well. So 2 times 10 would be 20. So if we had 10 bananas, we would have 20 apples. Not too bad. I went through that kind of quickly, so pause the video, write down anything that you need to write down to make sure that you know how to do this. So your first you're going to write an equivalent ratio if you have 3 bananas and 4 apples. A different ratio for bananas to apples this time. You get to choose what equivalent ratio you want to make. Totally up to you. Pause the video, do this now. One more way to find equivalent ratios is to use what's called a ratio table. When we do this, we're going to start with a ratio. For example, I just took the one from the 3 bananas to 4 apples. And we're going to fill in the rest of this table. To do so, the best way to do it is just to take your first pair of numbers and multiply them by 2. So 2 times 3 is 6. 4 times 2 is 8. So one equivalent ratio that you may have made in the is 6 to 8. That's totally fine. You can do it again, but this time we're going to multiply by 3. 3 times 3 would be 9. 4 times 3 would be 12. So we'd get a ratio of 9 to 12. You could do this times 4, you could do this times 5. It doesn't actually matter. If we want to do something really interesting, we could multiply this by 10 or something. So we multiply both of these by 10. So we'd have 30 to 40. And then if you needed to write one of these ratios, you would just write it using the normal ratio notation for whatever it might be. Nothing, again, too bad, just a different way to think about this. We are going to be using ratio tables in the next video as well. So this one is definitely worth at least writing down, even if it's not necessarily your preferred method. So our second you can use any method of finding equivalent ratios that you would like. The rebels on Hoth are badly outnumbered. For every 3 rebel troops, there are 7 snowtroopers. If Darth Vader commands 77 snowtroopers, how many rebel soldiers are there? Pause the video, take a moment to think about it. Remember, you can use a ratio table or just multiplying or dividing, whatever you need to do. But give it a shot. Pause the video. So things to remember from this video, if you don't remember anything else. To find an equivalent ratio, you need to multiply or divide the original values by the same number. If you want to multiply both of them by 2, great. If you want to multiply them both by 3, fantastic. If you want to divide them both by 4, amazing. It doesn't matter as long as you do the same thing to both numbers. Finally, you can also use a table to support your thinking if you need to. Totally optional, but it's not a bad idea. And we're going to be using them in our next video to compare 2 different ratios, so definitely a useful thing to know how to do. Our suggested practice problems, there are technically 7 of them, but are there really? I don't think they'll take you too long. The first section, you're going to find at least 2 equivalent ratios for each of these ratios in any way you like. You can use the table, you can just multiply them, it doesn't matter. Second one, the ratio of likes to dislikes is 17 likes to 1 dislike. You're going to write at least 3 equivalent ratios. Again, you can choose how you do them. And that's it. Hopefully you enjoyed this video. Hopefully you enjoyed the unnecessary transition that I stuck in there. And good luck.